Lenses. So in previous part, we discussed about mirror. In case of mirror, there is one side which is polished with silver or particularly a metal. But in case of lens, there is no polished part. So both side is particularly transparent. So there are two main types of lenses. One is convex lenses. This curve outwards and are fatter in the middle. Concave lenses, this curve inwards, a little like a cape, and are thinner in middle. So here figure shows some convex lenses and some concave lenses. Now there are two basic types of lenses. One is convex, another is concave. So in case of convex or concave lens, the incident rays after transmitted, they meet at a particular point. This point is called focal point, and the distance from the focal point to the lens normal is called focal length. And in case of concave, just particularly just imaginary point from which we can say the transmitted rays or reflected rays are immersed, we can consider, just imagine the immerse point, then this point and the normal of the lens is called the focal length. So a converging lens takes light rays and bring them to a point. A diverging lens, basically concave lens, takes light rays and spreads them outward. Movement of light through the lenses. In case of convex lens, in a convex lens, an incoming ray parallel to the principal, so the line center to the lens is called the particular principal. So the parallel ray to the principal axis is reflected through the principal focus. So if particularly the ray incident on the parallel to the principal axis, then the ray will refracted through the focal point. Okay. In case of concave lens, an incoming ray parallel to the principal axis is reflected so that it appears to come from the principal focus. So figure shows the same thing here. So two rays, parallel rays incident on the concave lens, then they refracted like that they this origin of the reflected ray at the point focal point F. Now movement of light through a lens. So we already discussed about that in case of parallel to the incident ray, they just meet at the focal point. The greater the curvature of lens, the more it bends light, and hence the shorter the focal length. So here the figure shows the same thing. The curvature in case of first figure, curvature is short, so then the focal length is high. And in case of second case, curvature is high, so that's why focal length is shorter focal length. Now, image type and location. How can we find out the image and location of the object? Convex lenses produce two different types of image depending on where the object is located. If the object is at a distance greater than the focal length of the lens, a real image is formed. A real image can be projected onto a screen. The figure shows the same thing, the real image produced here and object. If the object is at a distance less than the focal length of the lens, a virtual image is formed. This image cannot be projected onto a screen. So here shows the same thing. The image formed in the same direction same side of the object and basically larger image here. In case of concave lens, produce only virtual image. In case of concave lens, all image form is virtual image. Figure shows the same thing. Finding the focal length. How can we find the focal length in practical things? So rays coming onto a lens from a distance object are almost parallel and form an image very close to the focus. We can then measure the distance from lens to image to determine the focal length of the lenses.